All right, let's dive right into one of the weirdest, most fascinating ideas in all of science. We're talking about a rule from the quantum world that basically flips our whole idea of reality upside down. It suggests the universe isn't just there, it's actually responding to us.
You've probably heard this old riddle before, right? It's a classic philosophical puzzle that makes you think about what's real versus what we just perceive. And for a long, long time, that's all it was, a fun thought experiment. But in the bizarre realm of quantum mechanics, this isn't just a riddle. It's a massive clue to how reality itself is put together.
And here it is. This is the heart of it all. No question, no answer. In the quantum world, if you don't ask a question, there literally is no answer waiting for you. Think about a property of a particle, like where it is or how fast it's going. Well, that property doesn't really exist in a definite way until you actually go and look for it.
So how are we supposed to wrap our heads around that? Well, the best way is to stop thinking about it as just a passive observation. Instead, picture it as an active dialogue, a conversation. Every time a scientist makes a measurement, they aren't just taking a peek at the universe, they're actually starting a conversation with it. Okay, so in our day-to-day world, the classical world, we assume things are pretty straightforward. A baseball flying through the air has a specific position, whether we're looking at it or not. We're just revealing a fact that's already there. But in the quantum world, oh, it is a completely different ballgame. The very active measuring of asking the question, hey particle, where are you, is what forces that particle to have a definite position. The answer is literally created by the question itself. So how does this conversation actually happen? You can think of it as a simple three-step process. First, you ask the question. That means setting up your whole experiment, your measuring device. Step 2, you have the conversation. That's the actual physical interaction between your machine and, say, an electron. And finally, step 3, you get the answer. That's the result, the data point that pops up on your screen. You need all 3 steps to create the reality that you end up observing. And this leads us to what is maybe the most mind-blowing part of this whole idea. We're not just discovering some pre-written book about how reality works. In a very real way, we're actually co-authoring it, page by page, one question at a time. What's so wild is that the question you decide to ask fundamentally changes the reality you see. If you build an experiment to measure a particle's position, guess what? You get an answer about its position. But if you instead ask about its momentum, you'll get an answer about its momentum. The kicker is, you can't get a perfectly clear answer to both questions at the exact same time.
Now, to be super clear, we're not just talking about some trick of measurement here, or some limit of our technology. When we use a term like ontological level, what we mean is that we're talking about the very fabric of existence, the fundamental nature of what it means for something to be. This whole conversation is happening at the deepest possible level of reality. So, at the end of the day, the act of observing something and the property you're observing aren't really two separate things. They're an indivisible package deal. You simply cannot have the answer of a particle's location without the question of a measurement to find it. They're two sides of the very same coin, fused together at the bedrock of reality.
But why? Why does the universe act in this super strange conversational way? Well, it's not just random. There are actual rules. Think of it like a kind of grammar that shapes this dialogue. And that grammar is built on the absolute cornerstones of quantum theory.
These are the 2 foundation stones of our quantum grammar. First up is quantum uncertainty. The easiest way to think about it is this. The more precisely you nail down a particle's location, the fuzzier your knowledge of its momentum, where it's headed, becomes. And it works the other way around too. It's a fundamental trade-off. You can ask where is it, or you can ask how fast is it going, but the universe just won't give you a perfect answer to both at once. It's a core rule of the conversation. Then you've got complementarity. This is the idea that a quantum object can have what seem like contradictory properties. It can be a spread-out wave and a pinpoint particle. Which one do you see? Well, it depends entirely on the question your experiment asks. It's like having a conversation partner who can reply in either complex poetry or simple prose. It's your opening question that decides which one you get. And these aren't just limits on our tools. They are the fundamental reasons why reality has to be a dialogue. The answers aren't just sitting there pre-written. They are created in the moment, all according to these strange rules.
So after all of this, where does that leave us? What does it all say about the nature of reality itself? I mean, if it's not some static, pre-existing thing just waiting for us to stumble upon it, then what is it? The big takeaway here is a radical change in perspective.
The world isn't really made of things, it's made of events. Reality is a dynamic, always-on process of interactions. It's this huge network of questions and answers, a non-stop exchange of information between all the different parts of the universe. It's less like a static photograph and much more like an endless, unfolding conversation.
And that leaves us with one final, absolutely awe-inspiring question to chew on. We figured out that measurement, the act of asking, is what makes reality definite. But measurements are happening all the time, everywhere, not just in fancy labs. A particle of light from the sun hitting an atom on your desk, that's a kind of measurement. So if the universe is this constant cascade of answers being created, who or what is doing all the asking?